These are subdimension tables which are attached to the dimension tables. So one subdimension table I will explain so that you will having idea what I was speaking regarding a subdimension table. We have discussed one of the dimension tables in the earlier example for product. For product, like what you can capture: product ID, name, model, and variant you can capture. So for variant, again I will capture in another subdimension table, in another table. What was the variant name? What was the fuel type? And what was its ID? Okay, suppose if you take a car would be having different variants. For that variant, you will be capturing, like, because it would be having a lot of data, that you will capture for that variant what are the different characteristics that would be available for that variant. So you are for a dimension table, again you are having a subdimensional table. So this type of schema, when you are maintaining in your project, that is called a snowflake schema. Understood? Hello?
Yes, Surya.
Yes, yes.
Okay. The other one, next one is a galaxy schema that won't be generally used, but sometimes it might be used, but we need to know. But the two mainly used schemas in the data warehouse are star schema and snowflake schema. The third one also we have. I will just explain it for theoretical purpose. Third one is a galaxy schema. Galaxy schema would be having like two fact tables. In star and snowflake, you would be having only one fact table in the center, and around it in star, you will be having dimensional tables. And in snowflake, for that dimensional tables, again, you will be having subdimensional tables. Okay. The galaxy schema, you will be having two fact tables. This is how a galaxy schema looks like. Suppose two facts I wanted to capture. I'll explain with an example so we'll understand in a better way. Revenue fact I wanted to capture. So this would be one table. Then the other fact is product I wanted to capture. So I want to split the facts like into two different things. Suppose you take some gold company or from some finance company. So they will be having like different products. So that they will capture in one table like gold plus or something kind of thing, like different products. Like if you have like more than you have taken loan more than 1 lakh, those features would be different. If you take in a loan less than 1 lakh, those features would be different. So such that some plans they have, so those are their products that they will capture in a separate, they wanted to capture in a separate fact table. And the other revenue like with respect what other things they will capture regarding the date. The revenue measures what they will capture is date, units sold, and the sales number, sales amount. Product ID, product name, and for the branch here, branch ID, branch take. For the branch, you will capture some dimensions such as branch ID, name, address. And for the date fact, we will capture like date ID, year, month, quarter, or date. So these two fact tables would be sharing these two dimensions. And from here, this dimension regarding dealer, it is with respect to this revenue table only. For dealer, you will capture dealer location, dealer country, or dealer address. Everything would be captured in this dimension table. For product, again, you will capture variant ID, model ID, product name, and all in this dimension table. So here, dimensions are being shared by the facts. And the dimensions are being shared by the facts. Those dimensions we call as confirmed dimensions. And in this schema, you would be having like two fact tables, and around that you will be having dimensions, and sharing of the dimensions you can see in this schema. This is called galaxy schema. Understood? But main thing you just remember is like it would be having two fact tables, and the dimensions would be shared between the facts. And the dimension shared, when the dimensions are shared between the facts, those we call as confirmed dimensions. Uh, these points you remember. That is enough. That is more than enough. Is that fine? Hello?
Yes, yeah.
Okay. You don't take like everything to your mind. It will get more confusion if you take most of the things here. So only just remember these three things. We'll be having like two facts, and the dimensions should be shared between the fact tables. And when the dimensions are shared between the fact tables, those are called confirmed dimensions. And the question comes from here is, what is a confirmed dimension, they will ask. So that is the main question that would be coming from this session. Now we will see, and the other question that would be posed to you is, what are the differences between star schema and snowflake schema? The first difference is it contains a fact table surrounded by dimension tables in star schema. And in snowflake schema, the dimension tables are also would be having subdimensional tables. That is the first difference. In a star schema, only one join can create the relationship between the fact table and dimensional table. The concept of joins you would get like when we are discussing SQL. The join is a concept is nothing but like you will arrive at the final conclusion table joining like combining two tables based on your requirement. That is called a join. So a single join is sufficient in star schema to derive your requirement. But in a snowflake schema, you require more than one join to arrive at your business requirement. That is the second difference. The star schema is a simple design because like only center the fact table is there, and around it it is surrounding dimensional tables, and it is connected that. So the structure looks simple. And in snowflake schema, as the dimensions tables again would be having subdimensional tables, it looks like somewhat complex. So the snowflake schema is a complex design. In star schema, you would be having high level of data redundancy, like repeated things you might get because you are just capturing each and everything within the same dimensional table itself. So you might get repeated observations, and that's why like data redundancy would be there. And in snowflake schema, there would be a low level of data redundancy. As for each thing, like you are having again a subdimensional table, there would be less chance of capturing things like repeatedly. So there would be having like low level data redundancy in snowflake schema. Here in star schema, the processing would be obviously faster because only you're having a single join. In snowflake schema, it would be the process. The process would be slow. The processing of your query would be slow because like you are having multiple joins you need to make to get your required output. So these are the basic differences that you need to say when they ask like what are the differences between star schema and snowflake schema. What the point? Or you want me explain again the differences?
First two, Surya.
What? Again you require?
Yeah, I know the differences for the first 2 points.
First 2 points.
Mm.
First one is nothing but what we said. At the center, there would be a fact table and around it, it would be surrounded by dimensional tables. And for the snowflake schema, around the dimensional tables, again, those dimensional tables would be surrounded by subdimensional tables. That is the difference, right? That is the first point I have said. You haven't understood that?
Okay.
And the second point, single join. Join is a concept of combining two tables to get your required output as per the business requirement. In SQL, you would be learning the concept of joining, like what are the different types of joins available and when to use which join to get your required output. So that concept that you will get to know mostly in when learning SQL. So here a single join is sufficient to get your required output. As there would be only like a single dimensional table, you could fetch your required output using a single join condition in your query. But in Snowflake, you need to combine multiple tables. Here in star schema, if you combine two tables, you get your required output. But in Snowflake schema, you are having subdimensional tables also, right? So you need to do more than one join condition to get your required output. This point you understood or not?
Yes, Surya.
So these are the first 2 points. Other points like regarding data redundancy and processing and simple and complex, those points you understood?
Yes.
Okay, so at least like if you say like 3 to 4 differences, that would be more than sufficient. But you need to know like these are the major differences between a star schema and snowflake schema. So that's all for today's class. We will meet tomorrow. Like, so just we will have a recap of the things we have discussed today. Can you just tell me like what are the different things that we have discussed today?
Like the facts and dimensions we have learned.
First thing what we have discussed, metadata. We
For
have
the
discussed
first
like,
10 we
okay.
promised.
Okay. We have discussed metadata. What is metadata and what are the different types of metadata? Then we have discussed like what is a fact and what is a dimension.
Yeah.
Before that, we have discussed like what are the different data warehouse solutions that are available in the market.
Tools. Yeah.
And after that, we have discussed like what is a fact and what is a dimension. And then we have discussed different types of schemas. Star schema, snowflake schema,
Okay.
and galaxy schema.
Yeah.
And then we have seen the differences between star schema and snowflake schema. So these are the different topics that we have covered today.
Yeah.
Okay, I will upload the recording. You can just go through again.
Yes.
So any doubts in today's class, or we are good to close the sessions?
Yeah, I'm good. Yeah.
The Sneha.
Yes, no doubts.
Okay, I will just upload this recording and you can go through. And
Okay.
for yesterday's class, like when you come there, like you can discuss, or sometime we
Okay.
can connect again after
Okay.
you go through if you have any doubts.
Okay.
Okay. Thank you.
Thank
Bye.
you.